Today I'd like to demo something that I call the Quack hex box. Now this is actually, it's a cmoss, here I go doing this again, cmoss synthesizer. Now the reason I call it the Quack hex box is because originally this was a game called Quack. I got this for 49 cents at Salvation Army just to use the chassis. And basically the idea from this circuit wasn't mine, although I've been building similar type circuits for many years. This circuit came out of a book by a guy named Nick Collins, and it's, I believe it's called The Art of Handmade Electronic Music. It's N-I-C-C-O-L-L-I-N-S, Nick Collins. So I'd highly recommend that you can look for it on the web and find all kinds of information about it. If you get the whole package, there's even DVD video. It's a fantastic package. And Nick is very knowledgeable. He does like high-end kind of artsy installations for museums where he monkeys around with all kinds of real weird stuff involving audio and kind of hacked technology. So someone had recommended the book to me. It's more of a recent book, and I really enjoyed it, and I stole one of the ideas from this. Now back to the Quack hex box. There's a chip in here. It's a 14-pin chip. I think it's a cmoss. It's a 4049 hex inverter. I'm pretty sure that's the number. And basically, what this does, it produces 6 different notes, and those notes change pitch via these CDS cells. CDS cell is a photoresistor. Now, a resistor basically reduces the flow of electricity. Like your volume knob on your TV, that's actually called a pot or potentiometer. That's a variable resistor. It changes the amount of electricity, and you hear that reflected in the volume of the decibels that are changed. CDS cell or photoresistor is just like your volume knob on your TV, except there's no knob. It reacts to the amount of light or shadow that falls on the circuit. So the more light, the more electricity it lets pass through the circuit. If it goes dark, the note's going to go low. So you've got this chip in here, the power comes in, and then there's basically 6 little voices that sing, and each one is controlled by one of these cells. Now, in order to mix these signals together, you can try passive mixing with resistors, and then there's a method where you take diodes, and so all the voices come together and they kind of pass through these diodes, and then all the diodes connect and they go out to the speaker or the amplifier. Now with diode mixing, they don't just combine the sounds interact with each other, and different frequencies cancel each other out, so it's a much more distorted, otherworldly, or interesting sound. The challenge that I had with this unit was getting all of the voices on the chip to mix together without canceling each other out. What I didn't know is the proper way to mix one of these is with a 2-channel amplifier. Meaning, like, you have stereo, you could plug this into a set of computer speakers, and then you would only have 3 of these voices going to your right channel and 3 going to the left channel, because after you get about 4 mixing together on one channel, they start to cancel each other out and they don't sound as good. So this was a learning experience. On the next one of these that I'm going to build, I'd like to have stereo independent echo units with stereo amplifier and built-in stereo speakers, which will come out to be pretty cool, but it's a little more involved. So this was a real quick project. Took me 1 day to do. There is a volume knob on it. This is a kill switch, so when you hit this switch, it kind of stutters, goes on and off with the sound. Then there's the cells. I went ahead and mounted the cells thinking I was going to actually get all 6 voices to work. And actually they don't. But I think these cells, I wired them in there so they actually do perform a function. They do something. There's a power switch. Here's a battery power connector for your adapter to plug in. I didn't put a battery clip in this. I could later on. And it does have a built-in speaker with some real old fancy speaker cloth. And then there's an output jack for connecting it to an amplifier. So basically what I'm going to do now is we're going to take a break, and I'm going to open it up and do a close-up shot, explain a little bit more about how the circuit works. I'm probably going to draw a diagram. Then we're going to plug this unit in through, I have a delay unit hooked up to a mini amplifier that I made, my LM386 99-cent amplifier. You can go on, look that up on my channel if you're interested in a real cheap amplifier solution. So we're going to take a break, and we'll see what's going on inside this trash bin here. So here's the inside of the unit. Now the amplifier came out of it was a toy that I got from Salvation Army, probably something I paid $1 for. It looks like it's not a chip amp. It looks like there's some transistors in there. I honestly can't remember where that came from. You can see where I removed the original volume control and then ran those connections over here to my own volume that's outside. Here's our little 4 ohm speaker, power switch. I used hot glue to mount all the cells there. Just drilled a couple holes and sank the cells in. And here I have the main board mounted. As you can see, it's actually a very basic circuit. There's our integrated circuit chip. It's a total of 14 pins, 7 on each side, and you solder in a socket here. Because if you were to just solder that in, you'd probably heat it up so much from the solder and the iron, it might fry out what's going on inside here. That's pretty sensitive inside that chip. Although this is a CMOS chip, and they're notorious for being able to take a beating. You can hook it up backwards. You know, you could spill a glass of chocolate milk on there, strawberry quick, what have you. Would probably, you know, wipe it off and it would still work. And we got a capacitor for each channel, split off where each channel goes to its control. And then here are some resistors and diodes for blending all the sound together. So basically, power comes in, the sound's generated inside of here, goes to our amplifier with the volume control, and then out to the speaker with our power input, switch to turn it on and off, and then our output jack. So it's a pretty straightforward unit. Now, what I'd like to do at this point is I drew up a diagram. I'd like to explain a little bit more if you'd like to learn how this circuit works. Now, what I sketched out here is basically it's a picture of our chip. There's our CD4106 CMOS chip, 7 pins and 7 pins. And you've got a battery hooked up to it. So there's our positive 9 volt goes in on that pin. I think it will be number 14. And I'm probably wrong about all of this, but just for the sake of a quick explanation, minus 9 volt goes in on the other side pin. Now, for every other pin on here, inside here, we see a triangle, and we could think of that as an amplifier. So there's 6 amplifiers in here. Now, what I'd like to do is show you exactly what's going on. For each channel, we have this triangle. We like to think of that as our amplifier. Okay, now here would be our input, and here would be our output. Okay, so the power's coming in here, and it's going to amplify that and make it stronger. So what happens is we create a feedback loop. When this comes out, we send it to a capacitor, and a capacitor is basically, you want to think of it like it's a big battery. Okay, a battery, when you buy it, it's stored up with power, and then it releases that power into your flashlight or your radio. So this sucker, the power comes out, it charges up the capacitor, and then releases it. So that capacitor is constantly in a state of charging and releasing. Charging, it's on, off, on, off, on, off. So then we come over here, we come over to our CDS cell, that's our volume control, and that goes right back into the input. Okay? This would go out to the speaker. So basically, we have this poor amplifier is being tortured. It's creating a feedback loop. This is going on and off. So this is creating the oscillation or vibration which produces the tone. So if you put in a small one of these, you'll have a high pitch. If you put a big honking one or a larger one, you're going to have a lower note. Okay? That's how that works. And then to actually control where the range of the pitch is with that resistor. That's our CDS cell. Those are the little electric eyes, and it's just like your volume knob on your TV that you turn to turn up your volume, except it reacts on light. So it's basically just oscillating within itself, and then this goes out to the amplifier. So for our main diagram, we see here, sound is coming out of the amp. It's going through this capacitor, charging and releasing, setting an oscillation, and that is being throttled by our light cell, our electronic eye, which determines the pitch. So the sound splits off, it comes out, it goes through one of these diodes, because see, there's buddies in here. There's a bunch of these little noisemakers. Each one produces a voice. It's singing, and it gets mixed together to go to our main amplifier to amplify the sound for the speaker. They get all mixed together through these diodes or resistors. Diodes make it sound a little more interesting. So it's the same thing up here on top feeding down. Pretty basic circuit. Every other set of pins has one component, and then the sensor, 2 components. So hooking this up, I mean, anybody could do it. Take you a couple hours.